graph of linear inequalities today. Now remember, important definition, a line is a set of all points that are solutions to a linear equation, okay? And we've got a line here in slope-intercept form, and we know right off the bat that our slope is -2/3, right? And we know our y-intercept is 0, 7. And so I could plot 0, 7, see 9, 8, 7 would be right there. And then I could rise and run. Rise -2, run 1, 2, 3. Rise -2, run 1, 2, 3. I could rise +2 and run -1, 2, 3. And then I can get my line, line, everywhere a line, barking at the scene. Oh, sorry, that's sign, my mistake. 5-man electrical band. All right, anyway, gotta go on a diet there. Much too fat and a little too long. That's a song by Spirit, but that's another point. A different song. Anyway, and I'd like to change the world. That's 10 years after. I'd love to change your color. There we go, change your color. All right, now that means that every single ordered pair that makes this equation true, it shows up on this line. Any point I pick. If I pick this point here, 0, 7, it will work out true. If I pick, this would be what, -3, and this would be 9. So I'm saying -3, +9 is on the line. If I plug it in, I'm going to get -2/3 times -3 plus 7, and one woman is going to show up, and the two negatives will also cancel. And so I'll get 9 equals 2 plus 7, which is a true statement. 9 equals 9. Okay? The line shows me every possible point that will get me a true statement for this equation. Very, very important. But today we're going to be doing something a little different. Not really, though. We're going to be graphing inequalities. It's not going to be equal to. It might be greater than or equal to. Might be less than or equal to. Might just be greater than. Might just be less than. By the way, it's not okay to get these mixed up. It's not. It's not. You're in 8th grade. You're in honors algebra, 2nd semester. It is not okay to go, I forget which one's which. No, not acceptable anymore. Learn it. Okay? The less thans kind of look like L's. Okay? All right. Anyway, how am I going to do this one? Well, it's going to start off the same way as the one we just did. The slope is going to be 1/2. The y-intercept is going to be 0, -4. So I'm going to plot 0, -4, 1, 2, 3, 4. And then I'm going to rise and run. I'm going to rise 1, run 2, rise 1, run 2, rise 1, run 2. And I'll go down 1 and back 2. And then I'm going to draw my line, everywhere a line, barking at the scenery, breaking my mind. Except, because this is an inequality, there's more solutions to this line, to this equation, or inequality. There are more solutions because it doesn't have to be equal to, it can be less than, greater than, excuse me. Now, how do I find the rest of the solutions? We know what I'm going to do is I'm going to pick a test point. I know that every single point on this line makes this inequality true. Well, I'm going to pick a test point. Which test point do you think would be the easiest to work with mathematically? Which point in this entire graph do you think would give me the easiest time with mathematics? I think the origin, because its coordinates are 0, 0. That's going to be my test point. I'm going to plug 0 in for x and 0 in for y. If I get a true statement, I'll know that that is true. Right? Pretty obvious. So let's see what happens. Let's see, I'm going to put 0 in for y. 0 is greater than or equal to 1/2 times 0 minus 4. I'm going to simplify the right-hand side. 1/2 times 0 is 0 minus 4. 0 is greater than -4. That is true, isn't it? What that tells me is every single point on this side of the line is a part of the solution set. Any point you pick in there. You don't believe me? Pick another point. I can pick another one. But every single point on this side of the line, on the origin side of the line, will give me a true statement. You know, it's called shading. I shade this entire region, half a plane there. Okay, let's pick another random point. Let's pick, I don't know, Let's pick 2, 2, 8. Okay, I'm going to pick 2, 8. I'm going to plug 2 in for x and 8 in for y. I guarantee you're going to get a true statement. Y is greater than or equal to 1/2 times 2 minus 4. Well, 8 is going to be greater than or equal to 1/2 times 2 is 1, 1 minus 4. 8 is going to be greater than or equal to -3. It is true, isn't it? Let's pick a point on the other side of the line and see what happens. Let's pick a point on the other side of the line. All right, this time I'm going to pick the point, oh, I don't know. Let's pick 10, 0. 10, 0 is not in the shaded region. So let's put 0 in for y, and then we'll put 10 in for x. And I'll simplify the right-hand side. 1/2 of 10 is 5. 5 minus 4. 0 is greater than or equal to 1. Is that true? And notice this test point is not in the shaded region. Any point I pick below this line will not be in the shaded region. So it's pretty simple. It's almost the same exact thing, except you have to remember to shade. Now there is one more part to it, which I'll show you in a minute. But anyway, I'm trying to make my shading just a little more accurate there. You don't have to be perfect, just so you know it's everything above the line. All right, let's go on, try this one here. It's written in standard form, and just like in the last problem, I'm going to find out the necessary information. I think I'm going to get the slope, which is going to be -5 over -4, which is better said as 5/4, right? And then my x-intercept I think will be easier because it'll be a prettier number. So I'll get the x-intercept by using c divided by a. So my x-intercept will be 3, 0. So I'm going to plot the point 3, 0. Just double checking, make sure I don't have a sign error. So that's the point 3, 0. And then I got to do some rising and running. So I'm going to rise 5, 1, 2, 3, 4, 5. Run 1, 2, 3, 4. And I can go down 1, 2, 3, 4, 5. Back 1, 2, 3, 4. And I can draw my line. Okay. So hold on a second. Let me make this line go for miles and miles. I can draw for miles. Sorry, that's the Who. I can see for miles and miles. Anyway. Okay. Yay. All right. There's my line. Now, all those points make the inequality true. I need a test point because there's going to be other points that aren't on the line that make it true. I love to use 0, 0. When's the only time you can't use 0, 0 as a test point? What's that? Did you say it, John? When the line goes through the origin, you have to pick a different point. You might pick 2, 0. You might pick 1, 0. You might pick 0, 2. You have to pick a point that will be easy to work with, but the line cannot go through the test point. Okay, so I'm going to plug 0 in for x and 0 in for y. And I'm going to simplify the left-hand side, and we get 0 is less than or equal to 15. It is. 0 is less than or equal to 15. And so I will shade that side of the line. Now, some of you are thinking it's always going to be shaded above. No, it's not always going to be shaded above. You have to test. You have to test. There's no trick. You have to test. Okay? And so it'll be all the shading above. Shading cream, be nice and clean. Shave every day and you'll... Oh, that's shaving cream. Sorry, wrong song. Okay, so there we go. There it is. If I pick a point on the other side of the line and I plug it in, I'll get a false statement. You don't have to do that, but if you want to convince yourself of it, you go right ahead. All right, now this inequality looks a little bit different. You see it? Oop, where'd you go? Where'd you go? Get back here. Get back. Stop. Get back! Okay, y is less than 4x minus 8. All right, so first of all, I'm going to get my points. I know my slope is going to be 4 over 1, and I know my y-intercept is going to be 0, -8. So that's easy enough. So 0, -8 is right there. And for 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. All right. Now, there's a little trick here. See how it's not equal to? What's going to happen if I plug 0, -8 into this inequality? Let's see. -8 is less than 4 times 0 minus 8. So -8 is less than 0 minus 8, which means -8 is less than -8. Is that true? No, it's not. It's not true. So if I draw a line here, I'm telling you that 0, -8 is a solution. It's not. Here's how we rectify that. We draw a broken line. You saw in that practice part, they had some opportunities for dashed or broken lines. Okay. Let's see here. Properties. And let's see. There we go. Let me change the thickness of that. And I'll change the color. There we go. So you see, none of the points on the line make the inequality true. So I make a broken line to say they're not included. It's not unlike when we graphed on the number line. You know, remember when we graphed on the number line and we might have gone an open circle when it wasn't equal to and we shaded? It's very much like that, but instead of doing open points, we do a broken line or a dashed line. Now I still have to do my test point and figure out where the shading is, because that's where all the real solutions are. So I love to use 0, 0, especially when the line does not go through the origin. So 0 is less than 0 minus 8. 0 is less than -8. Is that true? It is not true. So I won't shade where the test point is. I'll shade the other side of the line. So I'm going to shade over here. There you go. There you go. Piece of cake. See how simple this is? You do it the same way. If it's not equal to, you have to have a broken line. And you have to use a test point, whether it's equal to or not, and see which side of the line you're going to shade. Okay, here's one more. If you want to try this one on your own, you go ahead. If not, if you're still getting comfortable, you can just watch me. That'd be fine. Watch me scroll all day and night. All right, there we go. Okay, I've got a standard form equation here. So I'm going to go ahead and I think I'm going to find the slope, which is going to be a positive 2/3 because a -2 over -3 is a positive 2/3. And the y-intercept looks friendlier than the x-intercept, so I'm going to find the y-intercept, which is going to be 0, -3. So go to 0, -3, rise 2, run 1, 2, 3, rise 2, 1, 2, 3, rise 2, 1, 2, 3. It's not equal to, so I make a broken line. Did you catch that? Did you catch that? It's not equal to, so you make a broken line. Not equal to, so you make a broken line. If it's equal to, it's a solid line. Oh dear. Okay, I need an arrowhead. I need to be skinnier, and I need to change the color. Okay, maybe I want a fatter one than that. There we go. Okay. All right. So, let's see. I need a test point. I love to use the origin, especially if the line does not go through the origin. So, I'm going to put 0 in for x. I'm going to put 0 in for y. You do the hokey pokey and you turn yourself around. That's what it's all about. True? Not true. I will shade the other side of the line because it's not true. What's true is true. What's false is false. This is not true, therefore it is false. So I will not shade the side the test point is on. Had I gotten a true statement, had I picked a different number, I mean, go ahead, pick a different point right now. Pick a point. What do you want to use? What's that, Boyana? Boyana wants me to use the point 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, Boyana, just for you. I'm going to go 2 times 5 minus 3 times 4, and that's greater than 9. Oh, negative 4, sorry. And this will be 10 plus 12, because negative 3 times negative 4. Is that greater than 9? You bet your boots. It's going to be 22. Doesn't look like a 22. Hold on a second. It'll be 22 is greater than 9. So, this is a true statement, right? All right, there you go. That's it for the video. Mr. Laurence signing off. Have a good night, everybody.